Hi everyone, we are the Tree Frog team, and let me show you our demo. Our demo is composed of several parts. First, we have our toe pad itself, looking at the hexagonal pattern. We also have a force gauge. Here is our pulley assembly, and then we are testing two fluids, water and mineral oil. To construct the demo, you can first attach the plastic panel as shown. Then you can attach our replicated toe pad to the pulley using the carabiner provided. The force gauge can then be attached to the opposite side of the pulley for proper measurement. We will be conducting 3 tests, the first with no fluid at all, then using water, and finally with mineral oil.
This is our toe pad model. The purpose of this is to show how heavy the initial model is. As you can see, it clocks in at just under 5 newtons or 500 grams of mass. This part of the demonstration is testing it with water to get a baseline. The toe pad model is placed into a bucket of water and then put on the acrylic plate. It needs to be pushed down to get some sort of adhesion force going. Then, when pulled upwards, you can see that the meter goes just beyond 5 newtons to show that it takes slightly more adhesive force to pull it up than simply the weight itself. This next part of the experiment pulls our toe pad model up laterally using our pulley system. Naturally, this will cause a slightly greater force due to the friction involved with the pulley system. And as you can see, the meter reads closer to 7 newtons. Upon finishing this part of the experiment, the toe pad model must be cleaned. The water can be dried off using paper towels, and then the acrylic plate must be dried off as well. This ensures a clean, dry surface for the next part of the experiment, which is necessary to avoid conflicting results with water and the oil.
So now we're going to repeat the process with mineral oil. It's a very viscous, thick oil you can find at a drugstore. We're going to dip the toe pad in the oil and then place it on the acrylic. Make sure you shake it around so it really sticks. Then you can use the force scale to pull on it and lift it up. We can see that for the mineral oil, the force is higher than for the water. For the water, it was around 5 newtons, and for the mineral oil, it's usually 6 to 7 newtons. So the kids can look at the numbers if they want to analyze that. Another way we can use the demo is we can hook it up to the pulley. Hook the pulley to the toe pad, and then you can use the force scale on the other side and pull against it. You can look at the forces there and compare them to the water as well. Next, we are just going to do a close-up of the toe pad breaking from the surface, so you can see that. Another way the kids can use the demo is they can do this all just with their hands instead of using the pulley or the force scale. This really helps them to feel the force, and you can really hear the suction break.
And that is our demo. Normally a tree frog would secrete a mucousy fluid, while here we are replicating this fluid using both water and mineral oil. It should be clear that the mineral oil, compared to the water, allows for a greater adhesive force to be generated between the toe pad and the acrylic plate. This is due to 2 reasons. The first is based on the phenomenon of capillary action. Capillary action is what allows the fluid to travel in between the channels of the hexagonal cells and disperse the fluid throughout the pad. Our toe pad is molded out of a hydrophobic elastomer, meaning that it repels water. And by this, a well-wetting oil should have no problem bonding to the walls within the channels of the toe pad, whereas water would struggle. The second reason is based off of wet adhesion. Now that the fluid is well spread out throughout the pad, an adhesive force is generated between the fluid and both surfaces of the toe pad and acrylic panel. Looking at the image and equation provided, the smaller the contact angles we can get allows for a larger adhesive force to be produced. This is why the fluid we choose to use for our demo is so important. We want a fluid that will wet well to both the toe pad and the acrylic. As mentioned before, our toe pad is hydrophobic, meaning it repels water and will give us a contact angle of around 90 degrees. Yet with the oil, it will wet very well to both surfaces and result in a very small contact angle, therefore producing a larger force as seen in our demonstration. That is all, and thank you for your time.